Good morning, Cole Fletcher here on behalf of the SPFA. This morning we're going to talk about some of the ways to do a changeover from one product to another. This is one of a few ways. This is the one I recommend doing. This is a way to reduce the potential for possible contamination from one type of material to the next, utilizing the system that we have in place here today. A couple of things we want to talk about is the items that you're going to need. Obviously, you're going to need gloves, eyewear, chemical resistant suit, a 5-gallon bucket, and paper towels to wipe off any spills or the pump itself. What we're going to do is we're going to get started. First thing you want to do is bring your hose heat up to about 75 degrees. And the reason we do this is because the B-side material is extremely thick. And today we're at about 60 degrees. So if we're at 60 degrees, it's going to pump a little bit slower than it would at 75. Try not to exceed 75 degrees. All right, once we get to our target temperature, we're going to go ahead and turn that zone on. All right, so now our hose heat is up to our target temperature of 75 degrees, which is going to make things a little bit easier. But notice I didn't turn on my B-side primary heaters. We don't want to turn our primary heaters on because we're going to introduce air to the system, and we don't want those heating rods exposed to air while they're on. So just our hose heat for now. Again, 75 degrees maximum. What we're going to do now is we're going to introduce air to our transfer pump. The first step you want to do is derate your transfer pump supply pressure to 0. If you don't have an air pressure regulator, some transfer pumps have a quick connect with an air valve on the side here. You're going to want to close that all the way off. And the reason being is when we plug this into air, we don't want this pump to go at an uncontrolled rate. We want to slowly increase the rate of speed to where we can handle the pump and not damage the pump as well. It's a very important step. So we're at 0. I'm going to introduce air to my transfer pump, and we're going to pump we're going to pump air from the bottom of the transfer pump through the supply hose to the machine back to the return line. And we're going to do this until air exits the return line. All right, so we're plugged in, and all I'm going to do is slowly increase the rate of speed by increasing the air pressure or the air flow if you don't have a pressure gauge. All right, we're going to start slow and slowly work it up to about 1 cycle per second. All right, now while this is cycling, you'll notice the material is exiting the return line. And we're going to do this until air is exiting the return line, and then we'll disconnect our air, and we're done with this step. So first things first is make sure your pump is nice and clean. We're trying not to introduce any contaminants into our new material. We want to make sure that we secure our bung adapter. This is so we don't lose any blowing agent during the spray process. So now we're done with our return line, but we're going to leave it in this drum for right now, because what we'll do is when we're done, we're also going to purge out some chemical through the return line. So just make sure that this is nice and secured. Now, again, make sure our target temperature is at 75. We're at 75. We're in the spray mode position. And once again, we're going to introduce air to our transfer pump, starting at 0 again. The reason you want to start over at 0 again is there's air, which is compressible in the system. If we just plug in 120 psi of air pressure, this pump's going to cycle extremely fast. We do not want to do that. So what we do is we start off at 0, plug our transfer pump in, and slowly increase our pressure or our flow rate until we build pressure on the system. And what I'm looking for on this pump here is about 66 psi of air pressure. If it's a T2 or a T1, you want to run about 100 to 120 psi of air pressure. And we are at 65 psi. All right, so now what we're going to do is that material has pressurized the air pocket, and that air pocket is going to push the chemical that's in our hose. So what we're going to do now is very carefully make sure that you have your gloves on and that you have your eye protection on. We're going to recover all the material in the hose, and we're going to do this until we get an air pocket coming out of the system. Okay? All right, now this is probably the longest part of this process. This can take, 5 to 10 minutes depending upon the viscosity of the material in the hoses. So now we've got air exiting the spray hose. All right, we're gonna let that purge off for a few seconds. After we discharge or disconnect our air, we're gonna let this bleed off for 30 seconds. Okay? Now, so what that has done is that has allowed us to collect all of the good material back into our original container. Now, after that material exits the hose, you've got air, and then for a 300-foot section of hose, you have approximately 2 gallons of what is called waste material. And the reason we have waste material is because once we introduce the new material to the system, it's not a hard line. It's not a solid wall that's being pushed through the system. It overlaps. So the residual material kind of lines the hoses and the traps and the Y strainers. And what it takes is, we find at 300 feet of hose with closed cell, it takes about 2 gallons of material to go through the system to kind of wash out the interior walls of the hose, the Y strainers, and all the good stuff. And what you do is you're going to collect 2 gallons of B-side material into a 5-gallon bucket that we will dispose of afterwards, and I'll show you the steps on how we dispose of that as well. So now what we're going to do is we're going to plug our air back in. We're going to run it up to 200 pounds of fluid pressure or 66 pounds of air, and we'll collect 2 gallons of waste. All right, so now we're going to collect our 2 gallons of waste material. Again, this can take a few minutes, so as soon as we're done collecting our 2 gallons, we'll come back to you in a second. Now our changeover procedures are done. We have flushed out the supply hose, we have flushed out the machine, we have flushed out the spray hose, as well as the return line. Now, it is my recommendation, once this machine is heated up, pressurized, and you're ready to spray, always spray out a test sample on some plastic or cardboard. Let that finish and check the cell structure. Make sure that you feel confident in the changeover procedure. Never just go straight to the job after doing a changeover. Now, our next step is going to be disposing of our waste material. We're going to do that in the next steps coming up. Now we've collected our waste material into our 5-gallon buckets. One of the things I did off camera is I collected equal parts of a component into a separate 5-gallon bucket. So now we have 2 gallons of B side, 2 gallons of A side. And what we're going to do is we're going to do half gallon at a time of B side and half a gallon of A side into a leaf bag, a 55-gallon trash bag, and we're going to make foam inside of our bag. And what that's going to allow us to do is that's going to allow us to dispose of our waste without having it handled by a chemical company in a liquid form. Now that we're making foam, we can dispose of this into a trash receptacle. Now, one of the biggest pieces of advice I can give you is once you've done this, I want you to make sure that you let these samples sit out in an area that's going to be away from a building or away from the woods, because if this material were to create too much exothermic heat, it could combust, and if it does, you want it away from a building. Now, this doesn't happen very often, but it is something that you need to understand can happen. If you're safe and you do small batches at a time, you're probably not going to have this happen, but just be aware. So what I'm going to do now is, I'm still in PPE. I've got my spill-proof suit on, I've got my gloves, and I've got respiratory protection this time. The reason I'm wearing respiratory protection this time is because we're going to be creating atomized fumes and gases coming off of our samples when we mix them together. So I'm going to go ahead and step over here, and what we're going to do is we're going to mix half a gallon of A to half a gallon of B. We're going to pour it in a bag and shake it, let it expand, and then we'll go on to the next one. And what we've made is we have made foam. All right, so this can be disposed of in your trash receptacle. What we're gonna do is we're gonna let this sit aside for 24 hours and then we'll throw it in a roll-off dumpster. Thank you, see you later.